Hi, welcome to Expertisor Academy. This is Giri, lecturer in physics. In this video, we discuss about the magnetic field at a point on axial line of a magnetic dipole. Look at here. Magnetic field at a point along the axial line of the magnetic dipole. That is bar magnet. Magnetic dipole is generated by bar magnet. See here, this is the bar magnet. This is south north pole. Here O is the geometrical center of the bar magnet. The distance between this O to S pole, that is L, O to N pole, that is L. Total distance is 2L. So magnetic dipole definition is product of pole strength into distance between these two poles, that is magnetic dipole. Consider one of the line which passes through two different poles. At point C, there is a one testing pole strength, that is QMC. This value is 1 ampere meter. This value is 1 ampere meter. Okay. So here Fn, force by the north pole. This is the direction of the force by the north pole. And Bn, this is the magnetic field by north pole. This is the magnetic field by south pole. This is the force by south pole. Okay. Next, the distance between north pole to this point C. So, what is the meaning of point C? At this point C, there is a testing pole strength, that is QMC, is placed. Okay, so simply testing pole or testing charge. The distance between point C and north pole, that is R minus L. R minus L. Why here written R minus L? Because distance between center of the magnet to this point C, that is small r. So that's why R minus L, that gives distance between N and C. Next, distance between S and C, that is R plus L. R plus L. Okay. So this is the two-dimensional representation of the force directions in the form of positive x and negative x, positive y and negative. This is the representation, field lines representation of force and magnetic field representations. Okay. Consider a bar magnet NS. NS as shown. Let N be the north pole and S be the south pole of the bar magnet. Each of pole strength QM separated distance by a 2L. Pole strength is QM. Separated distance is 2L. Next, the magnetic field at point C lies along axis of magnet at a distance from the geometrical center of the bar magnet can be computed by keeping unit north pole QMC, that is equal to 1 ampere meter at C. So what is the meaning of unit north pole? At point C, there is a QMC, that means north pole represents positive sign only. Positive sign. Unit north pole means 1 ampere meter pole strength. Okay, 1 ampere meter pole strength, that is positive. So that's why it is unit north pole. That's all. Okay. The force experienced by the unit north pole at sea due to pole strength can be computed using Coulomb's law of magnetism as follows. Coulomb's law magnetism as follows. Okay. The force of repulsion between north pole of the bar magnet and unit north pole at sea. See this force of north pole of the battery to unit north pole, that is Fn force by north pole mu naught by 4 pi into Q1 Q2 at the place of Q1, that is Qm, at the place of Q2, that is unit north pole, that is QMC, that is equal to 1 divided by R square. So here the distance between this north pole to this point C, that is R minus L. So that's why at the place of R square we written R minus L whole square. At the same time, force of attraction between south pole of bar magnet and unit north pole at sea. Here this force given by the south pole, so that's why it is negative. South pole always negative. Minus mu naught divided by 4 pi into Qm divided by R plus L whole square into I cap. Okay. The net force at point C. Force created by north, force created by south. So this equation, Fn equation and this Fs equation. So after net force at point C, see here from definition, this net force is the magnetic field due to magnetic dipole at point C. That means F is equal to D. F is equal to B. So that's why here represents B bar is equal to at the place of F bar. That gives mu naught by 4 pi into Qm divided by R minus L whole square into I cap plus minus of mu naught by 4 pi into Qm divided by R plus L whole square into I cap. So mu naught into Qm divided by 4 pi. So this is the common factor into 1 by R minus L whole square minus 1 by R plus L whole square into I cap. So after simplification, we get this relation, that is mu naught into 2R divided by 4 pi Qm into 2L divided by R square minus L square whole square into I cap. Since the magnitude of dipole, that is equal to Pm is equal to Qm into 2L. Qm into 2L. At the place of Qm into 2L, you place Pm. So that's why this one gives B axial line. Magnetic field at axial line, that is equal to mu naught by 4 pi into 2R into Pm divided by R square minus Y square whole square into I cap. Okay. So here, you see the important thing here. If the distance between two poles in a bar magnet are small, the distance between two poles in a bar magnet are small. So what is the distance between two poles in a bar magnet? See here, that is L value or 2L value. Distance between two poles, that is 2L. Distance between origin two poles, that is L. Okay. Compared to distance between geometrical center O of the bar magnet and location of point C. So R is double greater than L. So that's why R square minus L square whole square, that gives R power 4. So what happens here? Small r, this is the distance between O and C, is greater than compared to L. So that's why in this equation R square minus L square whole square, L square is eliminated. So that's why remaining term is R power 4. Keep the R power 4 at the place of before equation, that is R square minus L square whole square. At the place of denominator term, you have to keep R power 4. After that, we get the relation magnetic field at axial line, that gives mu naught by 4 pi into 2 Pm divided by R cube. So here Pm, that is equal to Pmi. That means I cap is the unit vector. This is the magnitude value. So this is the magnetic field at axial point of a dipole moment. Okay, so thanks for watching this video. For more videos, visit www.expertisoracademy.com. Thank you.